Hey guys, hope you're all doing well. I just wanted to make a video to show you how we can apply some of the trigonometry we've been learning. So I wanted to make a clinometer and use that to find an angle of elevation so that I can measure an object that I wouldn't be able to measure the height of directly. I didn't think to grab a protractor from the school, and mine doesn't have a hole in it, so I ended up just printing one off and gluing it to some cardboard for stability, punching a hole in it, which was fun. And then I've got a straw taped along the top, which is what I will look through when I'm trying to measure my angle of elevation. So I will look through this end, get to the top of the object, and you can see here that if I hold this level, the string rests at 90 degrees pretty well. Yep. And then when I take this and I look through it up at the top of the object, that will hang down, and then I can tell what angle I am looking up at that object at. So there's a super tall light post in a park near my house, and we are gonna go check that out and figure out how tall it is, get some measurements. Guys, I am at the park, and I'm going to measure that massively tall light post behind me. I realized after I got here and looked at how absolutely huge that is, that you definitely are gonna have to be really far away to measure an object that tall. I thought maybe I'd stand like 10 feet away. No, I'm 73 feet away from this to measure it here. And you will need, if you're gonna do this, you need someone to help you. So I've got my awesome husband somewhere back there, yep, helping me measure all this stuff. So yeah, and just for fun, I'm gonna take an estimate, and it's probably gonna be super wrong, but I'm gonna say 120 feet. My husband's shaking his head ridiculous. Okay, what's your estimate? 80. 80 feet? Okay, well, crap. We'll see. I guess now it's a contest. We'll see who's closer. Alright, so I'm gonna start measuring some stuff here then. I'll look through the straw at the top of the thing here. Okay, and Jeremy, you're gonna have to tell me the angle.
About 137 or 138.
Okay, let's go with 138. So that should be 48 degrees past 90. So angle of elevation, 48 degrees. My husband measured, my eyesight was 63 3/4 inches off the ground. So let's do some calculations. Woo! Okay, I know you were super stoked to see those calculations, but one thing first. I was thinking about it and I realized that 48 degrees is pretty close to 45 degrees, and if you remember, right triangles that have 45 degrees in the other two angles are isosceles right triangles, so the height is most likely actually going to be something somewhat close to 73 feet, which means my husband is almost definitely going to win this one, which I pretty well knew as soon as he said his estimate. I was so far off, I'm sure. But let's find out exactly how far off. So here's the setup we had that we're going to use to do our super quick calculations. I was standing 73 feet or 876 inches away from the light post, my eye level was 63.75 inches from the ground, and I was looking at the top of the light post with a 48 degree angle of elevation. So that gives us this right triangle here, and I'm going to go ahead and label this side X, and we're going to solve for that first, and then we'll add on the extra height to get the total height of the lamppost here. So if I label the sides with respect to this 48 degree angle here, X would be the opposite side and the other one is the adjacent side. And remember that tangent of an angle is the opposite over the adjacent, so we'll use that to set up our equation. Tangent of 48 degrees equals X over 876, multiply by 876, and that gives us about 972.90 inches. Now remember that that's not the total height of the light post, because we still have to account for the fact that my eyes were 63.75 inches above the ground. So we add that on, and that gives us a total height of 1,036.65 inches. Let's divide that by 12 to convert it to feet, and we get that the light post in that park is about 86.4 feet tall. So yeah, you can see that my husband's guess was so much closer than my estimate was, and that doesn't really surprise me. He's a lot better at estimating the size of things than I am, and he makes fun of me for it all the time. My original guess was going to be 100 feet, which would have been a little bit closer, but still not as close as his 80-foot estimate. But I saw myself next to that light post in the picture and just thought, man, that's so tall, so I really went overboard there. But there you have it. Now you've seen how people can actually use this math to find heights, distances, whatever, things that they can't really measure directly. So I hope you enjoyed it, and I will talk to you later.